Howdy folks, this is Mr. Ryan. This is going to be lesson 3.4 in our summer session of 9th grade math. And what we're going to do in this lesson is we are going to simplify radicals, and that means square roots and cube roots, okay? In order to be able to be good at this, it's actually a pretty, once you get good at this, you're really good at it. And it's just easy to solve these kinds of, or evaluate these kinds of radicals. I want to look at this one right here. These are two basic ones. It's just a basic idea you have to have is square root basically just means undo square. That's all it means. Okay, so if we do, so the square root of 5 squared is 5 because the square root is undoing the square. Okay, so square root of 5 squared is 5. It's the same thing with a cube root or a 4th root or a 5th root or a 6th root. Okay. If you do the cube root of 7 to the 3rd power, 7 cubed, you get 7. Cube root undoes a cube, okay? So the cube root of 7 cubed is just 7, okay? With that in mind, I want to take that idea just a little bit further, and let me erase this here, and I want to do a few other examples over here. And so what we have here is the square root of 13 squared times 19 times 31. Now I want to point out that the 19 is not squared and 19 is a prime number. 31 is also a prime number and it is also not squared. Because the 19 and the 31 are not squared and they are prime, they cannot be simplified out of the square root. They cannot be simplified out of the radical. So they will stay under the radical. But this 13 squared, because it's being squared, it can come out of the radical. Now I do want to point out, this is really, really important, that there is no addition going on, no subtraction going on under this radical. It is strictly multiplication, okay? So the simplifying that we're doing is strictly possible if there is just multiplication. If there is any kind of addition at all under a radical, just stop. Just don't simplify. There's very little simplifying you can do if there is addition or subtraction. You cannot simplify a radical that includes addition and subtraction. Okay, so please be very careful. All of the simplification we will do in this lesson will include only multiplication in or under the radical. Okay, and so here what's going to happen is this. Because the 13 is squared, the square root is going to cancel this, and we're going to bring the 13 out because the square root of 13 squared is just 13. But the 19 and the 31 cannot come out of the radical because they are not squared, and therefore the simplification here is going to be 13 times the square root of 19 times 31. And then we would go ahead and multiply 19 times 31, and we would get 13 times the square root of 589. Okay. There we go. All right. Now this one right here, this is the square root of 11 to the 3rd power times 7. Now here's what's interesting about this is that this is actually the same thing as the square root of 11 squared times 11 times 7. See, what we're doing is we're breaking up the 11 cubed into 11 squared times 11. And the reason we're doing that is because we can now take the 11 out of the radical, and then left underneath is the other 11. So we simplified 2 of the 11s. The third 11 stays under the radical, as does the 7. And we wind up with 11 times the square root of 77, because 11 times 7 is 77. We can do the exact same thing with a cube root. Okay, so with a cube root, 17 to the 3rd power, the cube root is going to cancel the 3rd power on the 17, and the 17 is now going to come outside of the radical. But this 23 squared cannot come out because a cube does not cancel a square. A cube root only cancels a cube. A cube root does not ever cancel a square. So this 23 squared has to stay under the radical. So the 17 can be simplified because it's 17 cubed. Then what we're going to have is cube root of 23 squared, which would now be 17 times the cube root of, well, 23 squared is 529. So we have 17 times the cube root of 529. And then here is something very similar that we saw just a couple minutes ago. We have 7 to the 4th power. The cube root, here we have the cube root of 7 to the 4th power. So we're going to separate this 7 to the 4th power into 7 to the 3rd power, because, watch this, let me do this over here. Remember, 7 to the 4th power is the same thing as 7 times 7 times 7 times 7. Well, we can take 3 of the 7s and make that 7 to the 3rd power, and then it's still being multiplied by the 4th 7. So this is the same thing as the cube root let's see here. There we go. Of 7 to the 3rd power times 7. Let's extend this a little bit. Times 11 squared, and that squared, the 11 can't come out because it's squared, it's not cubed, times 13. And since the 13 is to the 1st power, it also cannot come out. What we wind up with here is 7 times the cube root of, there's 1 7 remaining, there are 2 11s, so that's 11 squared times 13. And this winds up being 7 times the cube root of, a big number, well, big, kind of big number, 11,011. Okay? All right, so that's our little preview there. And what we're now going to do is we're going to go on to actually simplifying some radicals. All right, here's 4 examples. We want to identify the square root of 12. So here's what we're going to do. The very first thing you have to do every single time is identify, take the number under the radical. So we're going to write a radical here. And then do the prime factorization. Okay, so 12 is the same thing as 4 times 3. And 4 is the same thing as 2 times 2. And so what we have is 2 times 2 times 3, which is 2 squared times 3. So we want to do the prime factorization of the number and put that under the radical. So we have 2 squared times 3, okay? And now what we can do is the square root of 2 squared is 2, and then the square root of 3, we can't take the 3 out because it's not squared, so we just put on the square root of 3. And therefore, the square root of 12 is simply 2 square root of 3, okay? The square root of 45, we need the prime factorization of 45. Well, we know that 45 is equal to 5 times 9, and we know that 9 is 3 times 3. So this is 5 times 3 times 3. And so that's the same thing as 3 squared times 5. And so 45 is the same thing as 3 squared times 5. And now we can take the square root of 3 squared, which is 3. The 5 cannot come out of the radical because it's not squared. So we just leave the 5 under the radical. Now let's do the square root of 90. Okay, well, 90 is the same thing as 9 times 10. 9 is the same thing as 3 times 3. 10 is the same thing as 2 times 5. And so the prime factorization is 2 times 3 squared times 5. And so what we have here is the square root of 2 times 3 squared times 5. Now, the only thing that can come out is the 3 squared because it's squared. So we'll put the 3 on the outside, and then we'll leave the 2 and the 5 underneath. So we have 2 times 5, but we're not going to leave it. We're not going to leave it like that, okay? What we're going to do is we're going to multiply the 2 times 5, and we wind up with 3 square root of 10. 3 square root of 10. So square root of 90 is the same thing as 3 square root of 10, okay? Now lastly, let's do the same thing with 98. 98 is the same thing as 2 times 49. You can use a calculator if you need to. 49 So we got 2 times 49 is 7 times 7. So this is the same thing as 2 times 7 squared. And so the square root of 98 is the same thing as the square root of 2 times 7 squared. Now, the 7 squared, the square root of 7 squared is 7. But 2 has to remain under the radical because it's not being squared. And therefore, the square root of 98 is 7 square root of 2. Okay? Let's try some cube root examples. Okay, so the procedure for doing cube roots is exactly the same. Okay? We need the first thing we need is the prime factorization of the number underneath. Only now, instead of canceling squares, we're going to cancel cubes. So 40 is the same thing as 4 times 10. 4 is the same thing as 2 times 2, times 10 is the same thing as 2 times 5, and therefore, see what we have here? We have 2 times 2 times 2 times 5. So that's 2 to the third power times 5. Okay? And so this is the same thing as the cube root of 2 to the third power times 5. And so now the cube root will simplify or cancel the cube on the 2 cubed. So really all we'll have left is 2. Okay? So what's happening is this 3 is canceling this 3. And the 2 is coming out of the radical. That's what's happening. Okay? All right, so we're going to have 2, and then the cube root is still going to be here. The cube root, only under the cube root, is going to be the 5, because the 5 does not have a cube, therefore it cannot come out of the cube root. So we have 2 cube root of 5. Okay. All right, so for this one, the cube root of 54, let's identify the prime factorization of 54. 54 is the same thing as 2 times 27. 27, so 2 times 27 is 3 times 9, and 9 is 3 times 3. So we have 2 times 3 times 3 times 3. And so what we have is 2 times 3 to the third power. Okay, so this is now the cube root of 2 times 3 to the third power. And so the 3 to the third power can come out, but not the whole third power, just the 3, just the base. So 3 comes out, and then we have the cube root of 2. The 2 has to stay because it doesn't have a third, it's not 2 to the third power. Okay? All right, so now let's try this 56. Okay, so let's identify the prime factorization of 56. Well, I know 56 is the same thing as 8 times 7. Okay? And we know 8 is the same thing as 2 times 4. So we have 2 times 4 times 7. And we know that 4 is the same thing as 2 times 2. So we have 2 times 2 times 2 times 7, which is 2 cubed times 7. Notice we're looking for a cube. Okay, we're looking for a cube because of the third power. Okay? All right, so we wind up with, hang on. All right, there we go. So we wind up with the cube root of 2 to the third power times 7. And so now the 2, the base of the third power, can come out of the radical. That's the simplification. The 2 comes out, and then we have the cube root of 7, and that is our final answer. 2 cube root of 7. Okay. Now let's try the cube root of 108 here. Okay, well, 108. I know 108. We can divide by 2 at least because it's an even number. Remember, anything that ends with 0, 2, 4, 6, or 8 is even, so we divide by 2. So we have 2 times, and then we'll have, let's see, 108 divided by 2 is 54. Okay, so 54. Well, I know that 54, a second here. I know that 54 is also an even number, so I can divide that by 2. So I have 2 times 2, and then 54 divided by 2 is 27. 27 is 9 times 3. So this is now 2 squared. I'm going to leave it as 2 squared times 3 times 9. Okay, and then 9 is 3 times 3. So we have 2 squared times 3 times 3 times 3. So what we have here is the cube root of 2 squared times 3 to the third power. Okay? Now the 2 squared cannot come out of the radical because there's only 2 of them. Okay? There's not 3. We only have 2 2's. So those two 2's have to stay underneath. But we can cancel the cube on the 3. So we wind up with 3 times the cube root of 2 squared. Now 2 squared is the same thing as 2 times 2. That's 4. So our final answer is 3 cube root of 4. Okay? That's cube root of 4, not square root of 4. If it was square root of 4, we could simplify it to 2. But it's cube root of 4, which cannot be simplified. Okay? So that's our final answer there. All right, now let's try a few larger square roots. Okay, so for these, we're actually going to turn to Desmos because we want to save a little bit of time. Okay, we want the prime factorization of 294. Now, you need to know how to do the prime factorization of 294, dividing by 2, dividing by 5. Well, this isn't divisible by 5, but remember that we learned how to do the factorization here if we use the factor feature in not Desmos, I'm sorry, in NumWorks. Okay, so we can go here to the toolbox and select factor. Now let me remind you where this comes from. Okay, so if we started off, if we first hit the toolbox button, this is what we get. This is what it looks like. We got an arrow down, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we have to move the right arrow, and then we have to go down to factor. Okay, then hit OK. And I think we're trying to do 294. Is that correct? 294, and then hit execute. And here's what we get. Look at that. 2 times 3 times 7 squared. 2 times 3 times 7 squared. So right here, we're going to do the square root of 2 times 3 times 7 squared. Oh, well, the 7 squared can be simplified because the square root is going to cancel the square on the 7. So we have 7, that comes out, times the square root of 2 times 3. Those have to stay in because they're not squared. But 2 times 3 is 6. And so our final answer is 7 square root of 6. Okay? Okay, let's do this square root of 350. Once again, we're going to go into NumWorks and we're going to get the factorization of 350. And so we're going to arrow up, arrow over, press OK. Then we're going to change this 294. We're going to hit this backspace button. We're going to put in 350. And we're going to hit execute. And our factorization is 2 times 5 squared times 7. 2 times 5 squared times 7. So we're going to put the square root of 2 times 5 squared times 7. And of course, the 2 and the 7 cannot come out of the radical because they are not squared, but the 5 is squared, and so it's going to come out of the radical. And we're going to have back inside, staying inside of the radical is the 2 times 7, and 2 times 7 is 14. And so the final simplification is going to be 5 square root of 14. Okay. Now let's try this square root of 1890. And so we're going to go back to NumWorks here, and we're going to put in 1890. All right, here we go, 1, 2, 3, 1890, and hit execute. We got 2 times 3 cubed times 5 times 7. Okay, let's put that in. We've got square root of 2 times 3 cubed times 5 times 7. Now I showed you this before. This 3 cubed has to be separated. So we're going to go the square root of 2 times 3 squared times the third 3. We're going to include that times 5 times 7. Okay? And so now the 3 squared, the 3 can come out. We can cancel the square and take the 3 out. So let me point out, this square is going to get canceled. This 3 is going to come out of the radical. The 2 will stay. This other 3 will stay. The 5 will stay. And the 7 will stay. Because none of these other numbers have a square on them. So they have to stay under the radical. So we're going to take this oops, we're going to take this 3 out, then we're going to have the square root of 2 times 3 times 5 times 7. Now, 2 times 3 times 5 times 7, 2 times 3 is 6, 6 times 5 is 30, and 30 times 7 is 210. So we're going to have 3 square root of 210, okay? And then this one down here, this 2625, we're going to put that in numworks. Again, let's see, here we go, okay. And it's 2625, 2625. Execute, and we get 3 times 5 cubed times 7. 3 times 5 cubed times 7. So you have the square root. Square root of 3 times 5 cubed times 7. Now we got to separate the 5's. So we'll have 3 times 5 squared times the third 5. Oops, it's an ugly 5, but it's a 5. Times 7. So now we'll take the 5 out. The squared will get canceled. Okay? So this one is going to come out of the radical. Okay? And the 2 is going to get canceled. So we have 5 square root, and then we leave the 3, leave the other 5, and leave the 7. And now 3 times 5 times 7 is going to be, I think it's 105. So we'll do 3 times 5 times 7, and sure enough, 105. Okay. All right, so we have 5 square root of 105. Okay. All right, now let's just do a few more examples. We're going to do some larger numbered cube roots. All right, so we've got a few here that have larger numbers, as large as about 6,100 here, or almost 6,200. So what we're going to do is let's start with the cube root of 500. Well, let's get the prime factorization of 500, which you could do by hand, but we're going to do it in numworks. And so we're going to go ahead and do the factorization of 500. Right. And that's going to be 2 squared times 5 to the third. 2 squared times 5 to the third. So we have the cube root of 2 squared times 5 to the third power. And so the 2 is not cubed. It doesn't have a cube on it, so we're going to leave it as 2 squared. It's staying under the radical. But this 5 has a cube on it, and therefore the cube root can cancel the 3. This 3 can get canceled, and the 5 can come out of the radical. Okay? And so we have 5 cube root of 2 squared. Now 2 squared, we're going to work that out. 2 squared is 4, and so we wind up with 5 times the cube root of 4. Okay? And that is the same thing as the cube root of 500. All right, now let's do this one right here. Let's do the cube root of 3,500. So we're going to get the factorization of 3,500. Okay, here. And I'm just going to arrow over. It's 3,500. I'm just going to put a 3 here. Isn't that nice how when you just hit the button, it moves it over, it inserts, it doesn't. I like the fact that it doesn't overwrite. Then I'm going to hit execute. What I wind up with is 2 squared times 5 to the third times 7. Isn't that interesting? It's actually the same thing as what we just had. If you take 500 and multiply it by 7, that's when you get 3,500, and that's why it turned out very similar. Okay. All right. So this is going to be the cube root of 2 squared times 5 cubed times 7. The 5 is going to come out. We're going to have 5 cube root of 2 squared times 7. 2 squared is 4. Okay. Same thing as 4, and 4 times 7 is 28. So what we wind up with is 5 times the cube root of 28. Okay. Now let's do this one. This is the cube root of 756. So we're going to once again, we're going to go up. I'm going to get this one right here. And then we're going to erase the 500 and put in 728. Press execute, and we get 2 to the third times 7 times 13. Did I get the right? Oh, 756, not 728. Let's try that again. wrong number. Okay, it's supposed to be 756. Apologize. There we go. All right, so we've got 2 squared times 3 to the third times 7. All right, 2 squared, 3 to the third times 7. So we have the cube root of 2 squared times 3 to the third times 7. We can take the 3 out. Okay, we can take this out because it's cubed, and the cube root cancels the 3. It cancels the cube is what I mean. Cancels the cube, so the 3 is going to come out. And then we have the cube root, and all that's left underneath is the 2 squared and the 7. And again, 2 squared is 4, and 4 times 7 is 28. And so what we wind up with is 3 times the cube root of 28. Okay? All right, last one. Let's do this 6174. So we'll go ahead and factor it. Let's make sure I get this right. I'm going to set up 6174. Okay? So 6174. Hit execute. And we get 2 times 3 squared times 7 cubed. 2 times 3 squared times 7 cubed. So we get the cube root of 2 times 3 squared times 7 cubed. And the cube on the 7 is going to cancel. So the 7 will come out. And then we'll have the cube root of 2 times 3 squared. Well, 3 squared is the same thing as 9, and 9 times 2 is 18. And so what we wind up with is 7 times the cube root of 18, and that is our last example. And I hope this is a good video. I hope you understand. If you have any questions, then let me know.